Now we go. Now we are starting a new part of the mensuration. As we have discussed, there are two parts of the mensuration. One about the circle and another one is about the solid figures. So here today we start the second part of the mensuration, call it the solid figures. Solid figures basically we mean about the 3D figures. Let's say if I say circle, square, rectangle, triangle, and all these types of figures. They are called basically the two-dimension figures in which we only discuss the area of the circle, area of the square, area of the rectangle, area of the triangle, area of the trapezium, area of the rectangle, and so on. And if we talk about the 3D figures, basically three dimensions. So the 3D figures, let's say if we have a 2D figure in the form of a square, it's a 2D figure. You can say it's an empty space inside the square. But if I just convert this figure into 3D figure, I just make this figure and this form. Now, from the square, what we get? We get a cube. So from the square, you can say square is a 2D figure, and from the square, we get a cube, and cube is a 3D figure. And whenever we discuss about the 3D figures, normally 3D figures are the solid figures. And for the solid figures, because these three dimensions are representing here, we focus in two main parts or main unknown values of these solid figures. One is the volume, and second is the total surface area of that particular solid figure which is given in your question. Now, if we talk about only the solid figure, which is representing here by the diagram, which is cube. So, as we know, this cube comes from a square. So, all the sides, let's say side 1, side 2, side 3, side 4, side 5, and the front side is also 6. So, basically, it's a six-sided figure. It has six sides. And if I say what are the real examples of cube in a real practical life, where we can see the cube in simply, you can see the dice in Ludo. In Ludo, if you're playing Ludo, we are using die there. The dice which we are using in Ludo, basically they are the real examples of the cube. So if you need to find the volume of that particular dice in the shape of cube, normally the question representing in the question paper do not tell you the given figure is a cube or a cuboid or the cone. There might be possible the name of the figure is given, but they are representing the real scenarios. There is a part of the solid figure in which the cone is there and the cube is there. You need to recognize by yourself what are the parts of different figures representing the different solid figures which we study in the mathematics. So you should know about it. If all the sides of the figure are equal in the form of a square, then obviously it's a cube. And if you need to find basically in 3D figures, what we need to focus about the volume and the total surface area. So if I say what must be the volume of this cube, for the volume of this cube, we just multiply length, multiply by breadth, multiply by height. And as we see, this side is the breadth, this side is the height, and this side is the length. And as we discussed, we get cube from square. Cube we get from square. So square is a figure in which all the sides are equal. So all the sides of the cubes are equal. It means L, B, H, C, all the sides are equal. So we can simply say L multiplied by L multiplied by L, or B multiplied by B multiplied by B, or H multiplied by H. Whatever you want to do, it's the formula L cube. Basically, if you need to find the volume of the cube, you just need to take the cube of any side of the cube, because all the sides of the cube are equal in length. Now, if you need to find the total surface area, the second thing which we need to focus in the solid figures in finding the volume, and another is the total surface area. So if you focus there are six sides. There are six sides, or you can say six faces, six surfaces representing or shown in a cube. If I just select any one side of the cube, so any one side of the cube, if I say this is one side of the cube, and each side of the cube represent a square. And if I say what must be the formula for finding the area of the square, it's L square. So basically, there are six sides, and all the six sides of the cube are same. So L square plus L square plus L square plus L square plus L square. So basically, you can simply say 6L square is the formula for finding the total surface area of a cube. Basically, you need to clear your concept from where the cube comes. We have a 2D figure square, and from square we get cube. So if we have a clear concept, then we can easily generate the formulas without any rectification. Now we just move to another part, another solid figure. You can say the cuboid. And if you know from where the cuboid comes, cuboid is a 3D figure, and it comes from rectangle, which is a 2D figure. It's a 2D figure. So if you just find the area of the rectangle, for the area of the rectangle, you know its length into breadth. And in cuboid, we need to find the volume and the total surface area. So if I just make a rectangle in this format, like rectangle, two sides are equal and another two sides are equal, and not all the sides. It's a rectangle. And from the rectangle, we just make a cuboid. It's a cuboid. So cuboid is a 3D figure. It's a solid figure. It's a second figure which we are discussing here, and it comes from the 2D figure which we call rectangle. So if I need to find the values of this figure, what values we need to find? We need to focus on the volume. So what is the volume, or how can we find the volume of this cuboid? By multiplying length, breadth, and height. Let's say this is the length. Whatever variable you use for length, normally we use L, and this is the breadth, and this is the height. For cuboid, you need to focus on the parameters, which line representing the length, which line representing the breadth, and which line representing the height, because there are many questions you can see related to the rectangle in which we need to work, and the diagram representing the cuboid do not given in a question that it's a cuboid. There are different like they might be say in the question that it's a water tank, or it's a different type of box, you can say, in this rectangular format or cuboid format. So there are different wording used for representing this figure. So if you need to find the volume of cuboid, what we need to do, just multiply length with breadth and height. Simple. Okay, fine. Now, if you need to find the total surface area of this cuboid, so it's a little bit tricky. Why? Because if we need to find the total surface area, what we see in cuboid, we have six sides like the cube, but all the six sides are not equal. You can say this side, you can say let's one, and this side, the top and the bottom, both are same. Second, you can say this side and this side, they both are same. Same means in the dimensions. And if I say third, the front and the back is the same. So basically, the cuboid is divided into three different types of rectangle. Three different types of rectangle. So if I just focus on the first type of the rectangle, the first type of the rectangle, you can easily see this, and this. And if you need to find the area of this rectangle, we have L multiplied by B, L multiplied by B. You can easily see. And if I say, talk about the second, for second we have this part, this, this, and this. Just take out this part. It's also a different type of rectangle whose dimension are breadth and height. So if you need to find the area of this rectangle, you just do a breadth multiplied by height. Secondly, the third part is you can say the third part is the front. So for the front, you can say this, this, and this. So it represents the L and H. So you just multiply L into H. So you can say L multiplied by B plus B multiplied by H plus L multiplied by H. And as we know, each side is equal to another one. One has two sides, so we multiply with 2. And this also 2. This also 2. You do not need to memorize LB into LH into BH. You may memorize there are different variables used. L into B, B into H, and L into H. Both are different, and you need to multiply with 2, 2, 2. Normally, the question comes in the paper. They are saying there is a water tank, but the top, or you can say the lid of the tank is not present, or you can say the water tank is open. So if they are saying the water tank is open, let's say the question said open tank. So open tank means it do not have the top portion representing the first side. So what we do for the first side, we have L into B. So we just write L into B only. We not use 2 here. And obviously, if the tank is there, it has 2 both sides, this one and this one. It must be there. And if the tank is there, obviously it has the front and the back. You can say the third side, which represents the front and the back. You can say the wall, L into S. Sometimes what happens, we have the cuboid, but we do not use 2 here. Sometimes what happens, we give you the total surface area of a water tank or total surface area of any box, and they are saying how much a particular liquid or water must carry the given tank. So there are different type of questions you can easily see in the past papers. We will practice some of the past papers here. Now, we have our focus in this lecture about 3 figures. So third solid figure we talk about is sphere. So a sphere is a 3D figure, solid figure. Okay, and from where it comes? It comes from the circle. So if you know from where the 3D figure comes, you can easily generate the formula by yourself. You do not need to rectify it or too much calculation. Circle, let's say it's a circle. It's empty inside. There is nothing. It's empty inside. That is why we call it a circle. Or you can take the example of bangles, the females, or you can say the wristwatch, which we use. So they are the examples of circle. But if we discuss about the sphere is a 3D figure. It's a solid. So we represent this solid also in this format. But it must be filled. Filled means you can say for the real example, the football, the simple cricket ball, the tennis ball, any type of wall you may represent with the sphere, the marbles which we use in playing different games. So there are different examples. If we are studying physics, so we use a metal bob for the pendulum. So you can say the metal bob is an sphere. So it's very common in physics also. So for the 3D figure, we know for the circle, we just need to find the area. For the area of the circle, we have the formula pi r square. But if we need to find, if you focus on the solid figure, so for the sphere volume, so if you just have in our mind and just think about it, if you hold the football from our 2 hands, so there must be 4 portions, 4 circles that makes a football in a complete form. So basically for the sphere, we have the for the sphere, we have a formula, or if we discuss about the total surface area. For the total surface area, the area of the circle is pi r square. And for the total surface area, we have four circles that combines to make a complete sphere. We can say the ball or the football. So in simple, the total surface area of the football is 4 pi r square. Secondly, if we focus on, if we need to find the um, volume of the sphere. So we have a formula sheet also, and we need to memorize it, or we can drive the formulas also. And normally the formulas of spheres are given in the formula sheet. So in the question paper also. So if we talk about the sphere, so for the sphere, for the volume, we know the formula. It's 4 upon 3 pi r cube. So it's 4 upon 3 pi r cube is the formula for finding the volume of the sphere. So if you know about the sphere, so just discuss another solid figure which we called hemisphere. So hemi means half. Hemisphere. Hemisphere, you can simply say the half sphere. And obviously it's a solid figure. And for the real example, you may take the example of a bowl, which we use in the kitchen somewhere. And for the other, there are different types of solid figures or different types of, uh, you can say, uh, objects are there in our drawing room and different places in the half form, in half sphere. You can say just cut the football into two parts or just cut any ball into two parts. We just get the sphere. This is the sphere. And it's solid, so it must be filled. Okay. So for the sphere, basically it's a half sphere. So if I say what must be the volume of the hemisphere? So half means divided by 2. So 4 upon 3 upon 2, it becomes 2 upon 3 pi r cube. Or if I say total surface area, now focus here about the total surface area. Normally students confuse in the total surface area. What I told you, hemisphere is the half of the sphere. So if the total surface area of the sphere is 4 pi r square, you can say it's 2 pi r square, but it's wrong. Why? Because if you discuss half of the sphere is this portion, this is the half. But once we cut the sphere into two parts, we got this portion also. And if we see this portion from the top, it's a circular portion. It's in the circular shape. So it's also representing a surface whose shape is in circular face, and the area of the circle is pi r square. Just need to add pi r square. That's why for the total surface area of the hemisphere, we have the formula 3 pi r square. So how many figures we discuss today in this lecture is about the cube, then cuboid, then sphere, then hemisphere. Now we will do some questions from the past paper on these topics. Then we'll move to other figures of the mensuration in which the cone is there, the cylinder is there, the prism and the pyramid is there. All these figures are in paper with a huge marking, you can say 8 to 10 marks or till 15 marks. Both the papers, these type of questions come. Now we'll move to the past papers of this figures.